Imagine standing at the edge of the universe, gazing into its infinite expanse. There's a symphony of cosmic forces at play, a dance of energy and matter that stretches across the void. Out here in the deepest reaches of space are forces so immense, so powerful they defy comprehension. These are the titans of the cosmos, the rulers of the universe. They are supermassive stars, the celestial giants whose life cycles shape galaxies. They're hypernovae, the cataclysmic explosions that outshine entire galaxies. And there are the hypermassive black holes, cosmic leviathans that warp space and time. There's the deadly beauty of gamma-ray bursts, the universe's brightest fireworks. And finally, the collision of two hypermassive black holes, a cosmic event so powerful it sends ripples through the fabric of space-time itself. Buckle up, we're about to dive into the 5 greatest forces in the universe. First, we find ourselves in the presence of supermassive stars, giants of the cosmos. These spectacular entities are not your everyday stars. They are, in fact, an astonishing 10 to 100 times more massive than our own sun. With such immense mass comes an equally impressive gravitational pull, keeping their vast amounts of matter tightly bound. Supermassive stars are the cosmic powerhouses of the universe, their internal engines converting matter into energy at rates that dwarf those of smaller stars. The energy they produce is so intense that it creates a pressure pushing outward, counteracting the inward pull of gravity. This delicate balance between gravity and pressure keeps the star stable. However, this stability is only temporary. The greater the mass of a star, the more fuel it burns through and the shorter its lifespan. These celestial titans live fast and die young, in astronomical terms. Their life cycle is a rapid, intense burst of energy, followed by an equally dramatic end. What sets these stars apart is their endgame. When a supermassive star exhausts its nuclear fuel, it can't sustain the pressure to counteract gravity. The star's core collapses under its own weight, leading to a supernova explosion. This celestial explosion is one of the most energetic events in the universe, outshining entire galaxies for brief periods. But what remains after the dust settles? The intense gravitational forces at play during the supernova can cause the star's core to collapse further, forming a black hole. These black holes are the seeds for the supermassive black holes that lurk at the centers of galaxies, including our own Milky Way. So, in essence, these supermassive stars are the architects of the cosmos. They forge elements in their cores, scatter them across the universe in their explosive deaths, and sow the seeds for new stars, planets, and even black holes. These celestial giants, while impressive, are only the beginning of our cosmic journey. As we venture deeper into the cosmic abyss, we encounter the spectacular phenomenon of hypernovae. Imagine a star, a supergiant burning brightly in the vast expanse of the cosmos. It's a gargantuan entity, one that's lived for millions, perhaps billions of years. But like all things, it too has a lifespan. And when its time comes, it doesn't fade quietly into the night. Instead, it goes out with a bang, a cosmic spectacle of such magnitude and power that it's hard to comprehend. This is a hypernova. A hypernova is essentially a supercharged supernova, a stellar explosion that occurs at the end of a star's life cycle. But while a supernova is impressive in its own right, a hypernova takes things to a whole new level. It's an explosion so powerful that it's about 100 times the energy of a typical supernova. To truly grasp the magnitude of a hypernova, let's put it into perspective. A supermassive star, like the ones we discussed earlier, can unleash an energy equivalent to 1 trillion nuclear bombs. Now amplify that 100-fold. That's the energy of a hypernova. It's a force so strong that it can outshine an entire galaxy, even if just for a brief moment. But what triggers such a cataclysmic event? It begins when a supergiant star exhausts its nuclear fuel. The core collapses under its own gravity, creating a black hole or a neutron star. The outer layers of the star, meanwhile, are blasted out into space at nearly the speed of light, creating a brilliant display of cosmic fireworks. This explosion also results in the release of gamma rays, the most energetic form of light. These rays travel across the universe, carrying with them the story of the star's spectacular demise. When these rays reach Earth, they provide us with invaluable information about the universe's most powerful events. A hypernova's destructive power is truly awe-inspiring, but there are even more powerful forces at play. Beyond the fiery death of stars, we find the enigmatic, hypermassive black holes. These celestial giants are among the most intriguing and powerful entities in our universe. A hypermassive black hole is a black hole with a mass exceeding hundreds of millions, sometimes even billions of suns. They are the super heavyweight champions of the universe, and they don't pull any punches. These hypermassive black holes are not born overnight. They're the result of a cosmic evolution, formed by the accretion of mass over billions of years. Imagine a star so massive, its collapse under its own gravity triggers a supernova, leaving behind a black hole. Over time, this black hole attracts and devours surrounding matter, growing in size and strength. This process, known as accretion, continues for billions of years, resulting in the hypermassive black holes we know today. Now let's talk about the gravitational pull of these cosmic leviathans. It's so immense that nothing, not even light, can escape once it crosses a certain boundary known as the event horizon. To put it into perspective, imagine trying to climb a hill that becomes steeper the farther you climb, until eventually the slope becomes vertical. That's the event horizon, a point of no return. As something approaches a black hole and crosses the event horizon, it experiences a process called spaghettification. This is where the intense gravity of the black hole stretches it into a long, thin shape, like a piece of spaghetti. This occurs because the gravitational pull is stronger at the closer end than at the farther end, creating a stretching effect. These cosmic monsters are some of the most powerful forces in the universe, but our journey is far from over. As we venture deeper into the cosmos, we'll encounter even more mind-boggling phenomena. So, buckle up, space enthusiasts, for the next stop on our cosmic voyage, the cataclysmic gamma-ray bursts. Next, we face the deadly and mysterious gamma-ray bursts. These are not your typical bursts of light. Instead, they are the most powerful explosions known in the universe, releasing more energy in a few seconds than our sun will over its entire 10 billion-year lifespan. Gamma-ray bursts occur when a massive star dies, collapsing to form a black hole or neutron star. This collapse triggers an explosion known as a supernova, and in the most energetic of these, a gamma-ray burst. This process is so powerful that for a brief moment, the exploding star outshines the entire galaxy. These bursts produce beams of high-energy light, or gamma rays, which race across the universe at the speed of light. If one of these beams were to hit Earth, the results could be catastrophic. The intense radiation could strip away the ozone layer, exposing the planet to harmful solar radiation. But don't worry, these lethal light shows are extremely rare and usually occur in galaxies far, far away. The last one detected in our own Milky Way galaxy was over 1 million years ago, so the chances of us witnessing one are slim. Still, their potential for destruction is a stark reminder of the immense forces at work in our universe. Gamma-ray bursts are the universe's deadliest lasers, but there's one more force that overshadows them all. Finally, we arrive at the most powerful force in the universe, the collision of two hypermassive black holes. Picture this, two behemoths of mass and gravity, each one many times the size of our own sun, spiraling towards each other in a deadly cosmic dance. This is not just a meeting of giants, but a cataclysmic event of cosmic proportions. The dance begins millions of years before the actual collision. Drawn together by their immense gravitational pull, the black holes circle each other, getting closer and closer. Their immense gravity distorts space and time around them, creating gravitational waves that ripple across the universe. These waves are so powerful that they can be detected millions of light years away. As the black holes draw nearer, they spin faster and faster, reaching speeds close to the speed of light. Their gravitational fields merge, stretching and distorting the very fabric of space. This is a spectacle of cosmic proportions, a ballet of gravity and mass, played out on the grandest stage of all, the universe itself. Finally, in a burst of unimaginable energy, the black holes collide. In a fraction of a second, they merge to form a single, even more massive black hole. This collision releases more energy than 1 billion supernovae, making it the most powerful event in the known universe. This cataclysmic event is the apex of cosmic power, the greatest force in our universe. Our cosmic journey has taken us through the universe's greatest forces. We've traveled from the incandescent heart of supermassive stars, brimming with energy and incredibly powerful. We've witnessed the cataclysmic spectacle of a hypernova, an explosion of such magnitude that it outshines entire galaxies. We've peered into the dark abyss of hypermassive black holes, entities so massive and dense they warp the very fabric of space-time. We've experienced the terrifying beauty of a gamma-ray burst, a celestial event that radiates more energy in a few seconds than our sun will in its entire lifetime. Finally, we've stood witness to the collision of two hypermassive black holes, an event so powerful it sends ripples across the universe, distorting space and time itself. As we stand on the edge of the universe, we're reminded of the immense power it holds, a testament to the incredible forces that shape our cosmos.